We are drifting in a great ocean of space and time. In that ocean, the events that shape the future are working themselves out. Each creature and every world, to the remotest star, owe their existence to the great, coursing, implacable forces of nature, but also to minor happenstance. We are carried with our planet around the sun. The Earth has made more than 4 billion circuits of our star since its origin. The sun itself travels about the core of the Milky Way galaxy. Our galaxy is moving among the other galaxies. We have always been space travelers. These fine sand grains are all more or less uniform in size. They've been produced from bigger rocks through ages of jostling and rubbing, abrasion and erosion, driven in part by the distant moon and sun. So the roots of the present lie buried in the past. We are also travelers in time. But trapped on Earth, we've had little to say about where we're going in time and space, or how fast. But now, we're thinking about true journeys in time and real voyages to the distant stars. A handful of sand contains about 10,000 grains, more than the total number of stars we can see with the naked eye on a clear night. But the number of stars we can see is only the tiniest fraction of the number of stars that are. What we see at night is the merest smattering of the nearest stars, with a few more distant bright stars thrown in for good measure. Meanwhile, the cosmos is rich beyond measure. The total number of stars in the universe is larger than all the grains of sand on all the beaches of the planet Earth. Long ago, before we had figured out that the stars are distant suns, they seemed to us to make pictures in the sky. Just follow the dots. The constellation called the Big Dipper today in North America has had many other incarnations. Every culture, ancient and modern, has placed its totems and concerns among the stars, from a Chinese bureaucrat to a German wagon. But very ancient cultures would have seen different constellations, because the stars move with respect to one another. We can give a computer the present three-dimensional positions and motions of the nearby stars, and then run the patterns back into time. Every constellation is a single frame in a cosmic movie, but because our lives are so short, because the star patterns change so slowly, we tend not to notice it's a movie. 1 million years ago, there was no Big Dipper. Our ancestors, looking up and wondering about the stars, saw some other pattern in the northern skies. We can also run a constellation, Leo the Lion, say, forward in time and see what the patterns in the stars will be in the future. 1 million years from now, Leo might be renamed the constellation of the radio telescope, although I suspect that radio telescopes then will be as obsolete as stone spears are now. Or here's the constellation of Cetus, the whale. A million years ago, it may have been called something else, perhaps the spear. Now let's run fast forward through 1 billion nights. Millions of years from now, some other, very different image will be featured in this cosmic movie. In Orion, the Hunter, things are changing not only because the stars are moving, but also because the stars are evolving. Many of Orion's stars are hot, young, and short-lived. They're born, live, and die within a span of only a few million years. If we run Orion forward in time, we see the births and explosive deaths of dozens of stars flashing on and winking off like fireflies in the night. If we wait long enough, we see the constellations change. But if we go far enough, we also see the star patterns alter. The two-dimensional constellations are only the appearance of stars strewn through three dimensions. Some are dim and near, others are bright but farther away. Could a space traveler actually see the patterns of the constellations change? For that, you must travel roughly as far as the constellation is from us. Here, we're traveling hundreds of light years, circling all the way around the stars of the Big Dipper. The inhabitants of planets around other stars will see very different constellations than we do, because their vantage points are different. Here we are in the constellation Andromeda, or at least a model of it, next to the constellation Perseus. Andromeda, in the Greek myth, was the maiden who was saved by Perseus from a sea monster. This star just above me is Beta Andromedae, the second brightest star in the constellation, 75 light years from the Earth. The light by which we see this star has spent 75 years traversing interstellar space on its journey to the Earth. In the unlikely event that Beta Andromedae blew itself up a week ago Tuesday, we will not know of it for another 75 years, as this interesting information, traveling at the speed of light, crosses the enormous interstellar distances. When the light we see from this star set out on its long interstellar voyage, the young Albert Einstein, working as a Swiss patent clerk, had just published his epical special theory of relativity here on Earth. We see that space and time are intertwined. We cannot look out into space without looking back into time. The speed of light is very fast, but space is very empty, and the stars are very far apart. In fact, the distances that we've been talking about up to now are very small by the